Last episode we learned attention is n squared. Every token taxes every other token. So here's the consequence that runs this whole episode. If more tokens cost more than you think, then the context window isn't free space. What is it really? Think of the context window as a finite budget you respend on every single turn. It is not a place you fill up once. Each turn, the whole window gets fed back through that n squared attention. So every token you keep in there is rent you pay again and again. Now, how does the model actually run? Two phases. First, prefill. It reads your entire prompt in one big parallel gulp and builds up its internal understanding. This is the heavy bulk part. The cost scales with how long your prompt is. Then, decode. It writes the answer one token at a time, each new token depending on everything before it. Decode is the slow drip, prefill is the big upfront read. Knowing which is which tells you where the cost actually lives, and it lives in that bulk prefill. Here's the trick that falls out. Most of your prompts front, the system prompt, the tool definitions, the standing rules, is identical every turn. So if you keep it byte for byte the same and put it first, the model can cache the prefill work for that prefix and skip redoing it. That's prompt caching, and it's worth a fortune at scale. Let me show you the picture this episode is built around. A context window, fuel gauge filling up, with the model's recall curve laid over the top of it. Here's the window as a vertical gauge. At the bottom, the parts that never change: system prompt, tools, the standing rules. Above them, the conversation history, growing turn by turn. The gauge fills from the bottom up as the task runs. Now lay the recall curve over it, how well the model actually finds and uses a fact buried in the context. You'd expect it to stay flat until the gauge is full. It doesn't. Watch the curve sag long before the gauge tops out. There's a zone, call it the dumb zone, where you're nowhere near the limit, but quality is already dropping because attention is spread too thin. This is the practical meaning of last episode's n squared. So harnesses act before the gauge fills. Claude Code triggers compaction around 167,000 tokens, leaving a buffer. It summarizes old history rather than letting recall rot. The point isn't the exact number, it's that you intervene early, not at the red line. And on the caching side, Codex CLI never rewrites its history. It only appends, so the old prompt stays an exact prefix of the new one and the cache keeps hitting. Cursor does the cousin move, a static system prompt, so the cached prefix never breaks. Change the tools or the model mid-run, and you bust the cache and repay the whole prefill. So now we know the model's shape and its budget. Next, we put a loop around it on purpose, the React loop in depth. Thought, action, observation again and again, with the stop conditions and budgets that keep it from running forever.